All right, let's dive into a bit of a cosmic detective story. And like any good mystery, it starts with one single, absolutely mind-blowing piece of evidence. A number so big, you'd think it has to be a typo. Get this, 3,210,000 kilometers per hour. Yeah, you heard that right. Let that sink in for a second. We're talking fast enough to zip around the entire planet Earth in, about 45 seconds. It's just insane. So the question is, right, what in the universe is moving that fast? You might be thinking, okay, maybe it's some super advanced spacecraft or a rogue asteroid hurtling through space. Nope. The real answer is way cooler and, honestly, way weirder. It's not a solid thing at all. It's gas. Just gas. But it's being blasted out from the very heart of a galaxy. And listen, this isn't something out of a sci-fi movie. This is a real, honest-to-goodness measurement, and it was just made by NASA's new XRISM space telescope. This thing is giving us a front-row seat to some of the most powerful, most energetic events happening out there in the cosmos. Okay, so where is this all going down? Where's our cosmic crime scene? It's in a galaxy known as Messier 82. And trust me, it's the perfect backdrop for something this wild. So let's go take a look. Wow, okay, here it is, Messier 82. Some people call it the cigar galaxy. You can kind of see why. It's about 12 million light years from us, hanging out in the constellation Ursa Major. But just look at it. It's not peaceful, is it? You can see this violent, chaotic plume of red and blue gas just blasting out from its core. Yeah, this place is active. So M82 has a special classification. Astronomers call it a starburst galaxy. And the name is pretty spot on because that's exactly what it's doing. It's a galaxy that's just churning out new stars at a ridiculous, absolutely furious pace. So how furious are we talking? Well, let's put it in perspective. Our home, the Milky Way, we're pretty chill. We form maybe one new star every year. But M82, it's cranking out about 10 stars a year. 10 times the rate. And that insane level of activity, that's the key. That's the first clue to understanding these incredible winds. Okay, so we've got the what and the where. Now for the how. What is the engine behind all this? How does a galaxy even make wind that fast? Well, it turns out it's all part of this massive cosmic chain reaction. Okay, let's walk through it. It all starts with that crazy star formation, right? All these new, massive stars are born. They live fast, they die young, and they go out with a bang, exploding as supernova. We're talking countless explosions. All of that energy superheats the gas in the galaxy's core to a mind-boggling 25 million degrees Celsius. So now you have this insane pressure building up, and all that superheated gas has got to go somewhere. The only way out is, well, out. It just gets blasted away from the core in what we call a galactic wind. You know, it's actually a lot like weather here on Earth, just blown up to an insane cosmic scale. Here, air moves from high-pressure zones to low-pressure zones, and we call that wind. Well, it's the exact same principle in M82. The only difference is that the high-pressure zone is a 25 million degree furnace at the heart of a galaxy. Just a slight difference in scale. And the crazy thing is, for decades, this was all just a theory. A really cool theory, but still just an idea on paper. But now, thanks to some seriously incredible technology, we can actually measure it directly. So how did the detectives finally crack the case? Enter the hero of our story, the XRISM telescope. Specifically, an instrument on board called Resolve. Now, it's not like it can see the wind with a regular camera. Instead, it's looking for something very specific, the X-rays being blasted out by superheated iron atoms that are caught up in all that rushing gas. And by analyzing those X-rays, it's kind of like reading a fingerprint. Scientists can figure out the gas's speed and its temperature with a precision that was just impossible until now. This is a huge deal. I mean, think about it. It's the first real concrete proof for ideas that scientists came up with way back in the 1980s. It's this amazing moment where decades of theory finally become observed fact. But you know how it goes with science, right? You solve one mystery, and in the process, you uncover a brand new one. And here is the twist in our detective story. The brand new data from XRISM, it doesn't quite add up. It's revealed this major discrepancy, a case, you could say, of missing matter. It looks like this super powerful galactic wind Well, it can't explain everything that's going on. Okay, so here's what the science says. Based on the new measurements, the speed, the temperature, the models predict that this wind should be blasting material out of the galaxy equal to about 4 times the mass of our sun every single year. I mean, that's a staggering amount of stuff to be losing. But here's the problem. When we look at the galaxy with other instruments, the observations show it's actually losing about 7 solar masses of material each year. So the model says 4, but reality says 7. We've got a mismatch. And that leaves us with a brand new puzzle. Where are the missing 3 solar masses of gas going every year? The wind, as powerful as we now know it is, just can't account for all of it. Something else must be going on. Right now, the leading idea is that maybe this extra gas is escaping through other pathways, other channels that our current instruments just can't see yet. But that's just a hypothesis. For now, the case is wide open. It's a fresh lead for XRISM and other telescopes to chase down. And honestly, that's what's so cool about this stuff. Every time we think we found an answer in cosmology, it just unlocks a door to an even bigger, more interesting question. I mean, this discovery was amazing. It confirmed a 40-year-old theory, but it also slapped us with the reality that we still have so much to learn about how galaxies live and breathe and change over time. It really makes you wonder, doesn't it? What other secrets are these giant cosmic cities hiding from us?